Hey everyone, it's Bradley Bush with another algebra video for you. Today our topic is exponential functions. So this is a review, an introduction of exponential functions. Our to-do list. First of all, we'll give you a definition of an exponential function so you know exactly what an exponential function is. And then we'll give you some examples of exponential functions and discuss how to evaluate them. And how do you graph an exponential function? We'll talk about graphing an exponential function as well. And we'll also talk about how the base of the exponential affects the graph of the function. And then finally, we'll discuss all of the basic algebra function transformations as they deal with exponential functions. I'll also put all the timestamps for these items in the video description so you can skip ahead if you like. Exponential functions. So this is what an exponential function is. Here's the definition. First, though, we need to remember a couple terms. The first thing I want to discuss is that this thing right here, we'll call that the base. So the part that is not the exponent, the part that's below, kind of holding the exponent up, is called the base. And then, of course, we have the exponent. The exponent is the part that's up above the base, up to the right. So now that we have that out of the way, an exponential function is defined as any base a raised to the power of x, and x is the variable. A is a base, and a can be anything bigger than 0, but not equal to 1. You can also use y if you want instead of f of x. It's the same thing. But the exponential function itself is just the a, or some base, which is positive but not equal to 1, raised to some power, which is a variable. And there's a little difference between what you have probably done up to this point. If you're just learning exponential functions right now, you've probably been dealing with polynomials for quite a while. And there's a difference, right? Because when we have polynomials, like here we have x squared, the base was the variable and the exponent was the constant. 2 is the exponent and it's a constant, it doesn't change. The variable was the x and it was in the base here, and that's where you would plug stuff in when you evaluated, and that's kind of what you're used to. But exponential functions just kind of flip that. They reverse it. Now the bases are always constant, and the exponents are where the variables are. So they're completely switched. So that's something new that you will see with exponential functions. But once you have that down, I think exponentials are really not too hard. Here an example, a couple examples, 4 actually, of exponential functions. So f1 here is 2 to the x power. It's a classic exponential. You could have 10 to the x. It doesn't have to just be 2. Remember, the base can be anything positive but not equal to 1. So we could have 3 to the, and look at this, x plus 1. We don't have to have just x in the variable or in the exponent. We could have other things along with it. We could also have fractional bases as long, remember, as the base is positive but not equal to 1. So you could have 1/2 all raised to the x minus 1. Those are all valid exponential functions. And then how do we evaluate all of these? Well, you would evaluate them just the way you would evaluate anything else. If we're going to plug 3 into the function, then we'd take f1 here and we'll put 3 there. What is 2 to the 3rd power? 8. So not too terrible, huh? The next one, f2 is 10 to the x. Well, 10 to the x, we're going to put a 0 in for the x, and anything to the 0 power is just 1. So that's not bad. How about f3? f3 is 3 to the x plus 1. Well, if we're going to evaluate it at 1, we need to put a 1 there. So 1 plus 1 is 2. 3 squared is 9. And how about f4? f4 is 1/2 raised to the x minus 1. And if we're going to evaluate this at 2, that means we put a 2 there, and 2 minus 1 is 1. 1/2 to the 1 is just 1/2. So evaluating exponential functions is not really any more difficult than evaluating polynomials. You just have perhaps exponents that you have to deal with, but you guys can totally do that. How about graphing? Let's take the exponential function 2 to the x, and let's discuss how we would graph it. Well, of course, you could just plug it into Desmos.com or your graphing calculator. But what if we want to just have, an XY chart and then just kind of plot the points and connect the dots? Well, we can do that. So if we wanted to evaluate our function, which is 2 to the x at x equals -3, then we would need to put in -3, 2 to the -3. Actually, let's put in 2 to -2 here. Let's put in -1. Let's put in 0. Let's fill all these out really quickly. 1, 2, and 3. So what do we get out of this? So what is 2 to the -3? So 2 to the third power is 8, and the negative brings it down to the bottom, so we get 1/8. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. And then we have 2, 4, and 2 to the third power is 8. So we can take all of these numbers and plug them in. So we have coordinates, xy coordinates here, 0 and 1, 1 and 2, 2 and 4, and 3 and 8. And we can plot them. Where are they? So let's see. The first one is -3 and 1/8. So -3 and 1/8, that's just right down here at the bottom, right? Next to the x-axis, -2 and 1/4, that's slightly higher. -1 and 1/2, that's midway between 0 and 1. And then 0 and 1. By the way, all of these functions go through 0, 1. It's a good thing to note. And then 1 and 2, coming up higher, 2 and 4, and then 3 and 8. Nice. And then if we wanted to connect those, oh wow, you're going to watch how good my drawing skills are here. We'll see. Well, they're not. Okay, let's try that one more time. I almost said, not too bad. And then I took it back. I'm going to move that. That's how you fix things. You put the dot where the little curve is. That's how we roll. Come on. Let's color these in red so they're a little bit easier to see. All right, now we just need to label them, right? Let's put our labels up. So this one was A, this is B, this is C. We have D here as well. E, that's not a very good E. We have F, and then finally we have G. And this is our function 2 to the x. So you can see that as it moves to the left, it gets closer and closer to the x-axis. As it moves to the right, it gets higher and higher, and not only does it get higher, but it gets higher faster. So that's why they call it exponential growth, because the further right it goes, the faster it rises up. So that's a pretty classic looking exponential function. Now you can have them twist around the x-axis here. So you could have them twist this way and have them go up to the left and down to the right. Or you could flip them over the x-axis and have them come up. But they generally have this fast-growing and asymptotic shape. Let's look at the graphs of some other exponential functions. For example, y equals 3/4 x, which you see right here in purple. Notice that it goes up to the left and down to the right. Interesting, huh? How about y equals 1/2 x? It also goes up to the left and down to the right, but it goes up faster than 3/4 does as a base. So both of these two functions, 3/4 x and 1/2 x, they both have a values that are between 0 and 1, so they're fractional. So you notice that all the fractional bases go up to the left and down to the right. So they're kind of flipped around the y-axis from the one that we just looked at, which was y equals 2 to the x, which was right here. You can see y equals 7 to the x also. And notice the larger the base, the quicker it rises up. So the blue graph here rises up quicker than the red graph, which is y equals 2 to the x. And both of these two that rise up to the right and down to the left, they both have base values that are bigger than 1. And another cool thing is they all go through the point 0, 1. All shall pass through the point 0, 1. Really important note. Also, we have a horizontal asymptote. We have a horizontal asymptote at x equals, or y equals 0, which is the x-axis. So that gives you kind of a feel for different types of exponential functions. Let's talk about transformations with exponential functions. I have videos that talk about transformations of a lot of other graphs, and you can check those out on my Algebra playlist. But this specifically talks about the exponentials. So we have vertical shifts. If we add or subtract a constant outside the function, then we move either up or down, depending on the sign of the constant. We can shift horizontally by adding or subtracting a constant inside the function, and those move us left and right, respectively. So those inside the function move the opposite direction of the sign. So if it's a negative constant you're adding inside the function, then you move to the right. You can also reflect about the x-axis or about the y-axis. If you flip it around the x-axis, you're multiplying by negative on the outside. And if you multiply by negative on the inside of the function, meaning up in the exponent, then you're flipping it over the y-axis. We also have vertical shrinks and stretches. If you multiply by a constant on the outside and that constant's bigger than 1, then you are stretching it vertically, meaning you're pushing it away from the x-axis, stretching it up and pulling it down. If that constant that you're multiplying out in front is between 0 and 1, then you're shrinking it, meaning you're pushing it towards the x-axis from above and below. Now the horizontal stretch or shrink has a constant multiplied up inside the function in the exponent. If that constant's bigger than 1, then you are shrinking it horizontally, meaning you're pushing it towards the y-axis from both sides. And if that constant in the function is between 0 and 1, then it is a horizontal stretch, meaning it pushes it away from the center, pushes it out towards both sides or away from the y-axis. So that's it. Hope this was helpful. Hope you enjoyed this introduction to exponential functions. If you liked it or it was helpful, please subscribe to the channel and give me a like, and thanks for watching.